All right, let's take a look at select form to find quadratic feature. This is going to be a very quick video because knowing the different forms, you can get the different characteristics really, really quickly. So standard, factored, vertex. Standard is A, B, C. Factored has 2 parentheses and vertex has 1 parentheses, okay? So let's run through it really quickly. Is this happy or sad? So looking right at the beginning, that is happy. Is this one happy or sad? Looking right at it, it's a negative, so that's unhappy, sad. Looking at that one, that is also a sad. So I can find happy or sad no matter what form they give me. Can I find the vertex from standard? I can using the formula, right? So in fact, I'm actually just going to write minus b over 2a, but not very quickly. What about here? I can find the vertex from here, from the x-intercepts, and then draw an x-axis. Okay, but not very quickly. What about from vertex form? Yes, I can just look at the vertex form and see what my vertex is. Remember, my vertex is these two right here. It's going to be the opposite of what is inside. So -4 is going to become +4, and outside stays the same as 12. So these are characteristics that you can grab really quickly without any calculations. All right, so looking at the next one, is this a maximum or minimum? So given that it is a sad face, the vertex is located right there, which is a minimum. Do I know what that minimum number is? No, not without calculating this. So I'm going to shade this as I don't know it immediately. All right, looking at this sad face, this is a maximum. It's right at the top, so this is a maximum. Can I see what that vertex is to see what the maximum is? Not at all. So I'm going to go ahead and shade that out. So this is just what can I get really quickly from the different forms. All right, this one is a maximum because it's at the top. All right, do I know what that maximum point is? Yes, I do. It's 12. Okay, so my highest point is 12. That's how high the graph is. All right, axis of symmetry. Remember, once you have your vertex, you have axis of symmetry. So do I have my vertex here? No, I'd have to calculate it to get my axis of symmetry. What about here? No, I don't have it for factored form, but in vertex form, automatically, as soon as I find my vertex, I know my axis of symmetry, which is always, make sure you say x equals, and then the x value 4, okay? Domain, no matter what form I'm in, I can find domain. It's always all real numbers, okay? So that means, and I'm sorry, I forgot to fill this out too. For any of these, I can find domain immediately. For any of them, I can find whether it's a max or a minimum. For any of these, I can tell if it's a sad or happy face. So this one works for all, this one works for all, just the max and minimum, this one works for all. In terms of range, again, I can't tell the range unless it's graphed for me or they give me the vertex, right? That's why these two are blank. I can work it out, but I can't tell immediately. So from standard and factored, I can't tell, but from vertex, I can tell because I already have the vertex. So what's the range? So to see the range, you have to look at the smiley face. You can see that starting from the bottom, it comes from -infinity and to the top of the y value of your vertex, which is 12. Then it's going to be open and a closed bracket. Okay, so range cannot be told from all of them. All right, still moving through the characteristics. So still the same exact question, standard, factored, and vertex. Can I tell if it's increasing and decreasing? Again, without without understanding what the vertex is, I cannot tell if it's increasing or decreasing. So since I don't know these vertex without calculating it, the only one I can tell is for the vertex form. So where is it increasing and where is it decreasing? It's very important for you to have a picture. So here's the one with vertex form. What is it doing on this side? It is increasing. What is it doing on this side? It is decreasing. All right, to the what of this line. So this is the axis of symmetry. So immediately, anytime I say increasing and decreasing, I'm looking at axis of symmetry, which is x equals 4. So what you're going to write is x blank 4, x blank 4. And you just need to know whether it's to the left or to the right. So this side is to the left, right? And how do I say left? Less than. And how do I know that? Because this is an arrow pointing to the left. So it is increasing, so I'm looking increasing to the left. So I'm looking at increasing to the left. Okay, what about where is it decreasing? So again, I'm looking at where is the graph decreasing? It's decreasing on the right-hand side of the axis of symmetry. How do I represent right in math? Greater than. How do I know that? Because it's an arrow going to the right. So greater than the axis of symmetry, 4. So it's increasing and decreasing only if you know the vertex or if you're given the graph. All right, what about the x-intercepts? All right, I can't tell the x-intercept from here just by looking. I can tell the x-intercepts from factored form just by looking. So if I look at this, what are my x-intercepts? It's the opposite of whatever is already inside, right? So this is going to be x equals 3 or 1. And you can write this as well in coordinates. How do I write that in coordinates? 3, 0, because the y is 0, because that's crossing, and 1, 0. So 2 different ways of writing it down, but means the same thing. Can I find my x-intercept from vertex form? Not by looking. I can calculate, but not by looking. All right, if it's positive or negative, that means is it above the x-axis or below the x-axis? Okay, so positive, above x-axis, and negative below x-axis. All right, again, I can't tell that unless I know what. What would I have to know? I'd have to know the x-intercepts. Okay, so I'm going to just draw this one really quickly. So remember, for this factored one, it is an unhappy face. So I'm going to draw an unhappy face. Somewhere it crosses at 2 points. And I know it's 2 points because I have 2 x-intercepts. So it crosses at 2 points. So if positive is above the x-axis, that's everything here. That's positive above, and negative is below the x-axis here and here. Okay, so I'd only know them if I know the x-intercepts. That's why these are crossed out. All right, so where is it positive? Well, it's positive in between the 2 x-axis. So how do I represent that? I can say x is in between. What are the 2 numbers? And you got to do least to greatest. So the first one would be 1 and then 3. 1 and then 3. That's when it's positive. That's when it's above the x-axis. When is it below the x-axis? Well, it's at 2 points, here and here. So everything to the left of this point, and remember, how do I represent left? Less than. So everything to the left of this point, which is 1, and everything to the right of this point, which is 3. So once you know your x-intercepts, you can say whether it's positive or negative. All right, that's the only one you can tell if you have the x-intercepts. Finally, the last one, the y-intercept. All right, really, really quickly, just by looking, I know the y-intercept is 42. You can write that as y is equal to 42. You can write it as 42, or you can write as a coordinate, which would be x is 0 and y is 42. Okay, so different representations. Now, can I find the y-intercept for this? Yes, but I have to calculate it. Okay, and I don't feel like calculating it. But if I was to calculate it, I would just set x is equal to 0, then plug in for both of these. Okay, so you can really calculate it really quickly. Like 0 is x here, 0 is here. So this will be -1 times -3, which is +3 times -2 is -6. So that's a y-intercept. So it's easy to plug in, but you still have to calculate. So the fastest one to find the y-intercept would be standard because you can just look at it. All right, so let's summarize what we've just found out. In summary, use standard form to find what? All right, so let's take a look at standard form. So standard form, I can find happy or sad, okay? I can find domain. So I can say domain. I can find whether it's a minimum or maximum, but I can't find the value. So I'm just going to leave that blank. All right, so standard y-intercepts. So domain and y-intercept. All right, use factored form to find. So factored form, I can tell if it's a maximum or a minimum, but I can't tell what it is. I can find domain. So factored would be also domain. And actually all of them will be domain, so I don't have to keep writing that down. Okay, so domain, factored. And factored, what else can I find? I can find the x-intercepts, positive, negative. X-intercepts, positive, negative. So x-intercept, whether it's positive and negative. Now I can find the y, but it takes a little bit of calculation. Finally, the vertex. Vertex is the one I can find the most. So I can find the vertex, the max min. So let's go ahead and write that. Vertex, whether it's a max or a minimum, because this one I can tell what the actual maximum or minimum value is. Axis of symmetry, range, Axis of symmetry, range. So this is the one that has the most characteristics. Increasing or decreasing. Increasing slash decreasing. Okay, go ahead and also copy that down. We're also going to look at what is happening at end behavior in all standard factored and vertex form. So as x is going to negative infinity, that means x is going to negative this way to the left. What's y doing? As x is going to positive infinity, that means x is going this way to infinity to the right. What's y doing? Okay, so knowing that our standard is a happy face, okay, my end behavior is that no matter whether x is going to the left or right, y is going towards the top, which is positive infinity. So for standard, for this example, it is going to infinity. For my factored form, because my factored form was negative, it is going to negative infinity for both. So whether it's going to the left or whether it's going to the right, it is going to negative infinity. Finally, for your vertex form, because that was also an n, it is also going to negative infinity. So whether you're going to the left or to the right, you are going to negative infinity. Only for quadratics is this going to be the same, like infinity, infinity, negative infinity, and negative infinity, negative infinity. Those have to be the same for quadratics. Okay, so that means no matter what form, standard factored or vertex, we can find the end behavior. So add end behavior on each of these. This is a listening check, color in end behavior. Color in end behavior. Okay, so this is a quick summary of which one is the fastest to find which characteristic. What I want you to do is do this first example, and I'm going to start you off, and then you're going to do it, and then we'll do the second one together. So starting you off, fill out the characteristics using the fastest form and write down the correct notation. Entire table will not be filled. So the ones that have the blanks are not going to be filled. So you can do whether this one is sad and happy, whether this one is sad and happy, whether it's sad and happy. For vertex, the only one I need is this one. Min or max, and remember the only one that you can tell what the actual min or max is the vertex. So what I'm going to do is go ahead and color this, because you won't know the value for that. Color that side, but you are going to be able to tell me if it's a maximum or minimum. Tell me the domain for each one, the range only for the vertex, because you're not going to be able to tell from these two really fast. Axis of symmetry only for the vertex, increasing, decreasing, y-intercept. Actually, for y-intercept, we're not going to do for the vertex one. We're not going to do the calculations, or for the factored. So go ahead and shade that in. Okay, but you can tell me the y-intercept from standard. The x-intercept only for factored form. What are they? And then from the x-intercepts, whether it's positive or negative. So go ahead and try this, and then we will do this one together.